Okay, looks like you're a little bit short on examples for section 1.6b, so I'm going to give you a few more in that section, starting off with number 12 for MAC 1105. Okay, when you are solving these absolute value equations, the first thing you want to do is isolate the expression that is in the absolute value symbols. So in order to do that, you're going to remove this 8 first. Make sure I have my calculator if I'm going to give some more examples here. So just subtract 8 on each side and you will have 24. Then the next thing that you're going to do after you get the 24 is divide this 4 right off the front because it's a multiplier. So get rid of it by dividing. Don't forget to do the same thing on the right side as well. That leaves you with 6. And then what you have left inside the absolute value symbols is 8 minus 7/5 x. Okay, then when you're going to solve these absolute value equations, once you isolate the absolute value expression, you're going to remove the absolute value symbols by taking this expression and saying that this value that's inside here could have been 6, and then when you take the absolute value, it'd be equal to 6, but it also could have been -6, this entire expression inside the absolute value. So that gives you the justification to set up 2 separate equations. The value in here could have been 6 or -6, and then the absolute value would make it 6. So you state that. Okay, now you're going to get 2 different solutions. Students oftentimes forget to set it to the equal to the negative value so that they can get the other solution. Now you're faced with a fractional equation, so you want to get rid of the fraction that's there, which means you're going to have to multiply by 5, but that multiplication by 5 also affects the 8. You end up getting 40. When you multiply this by 5, it just kicks out the denominator, leaving you with 7. And then when you multiply the 6 by 5, you get a 30. Okay, now you have a nice clean equation. Solve for x. See if I can squeeze this in. So this will be -7x. I'm going to bring this 40 over here. And it's going to be -40. And then you'll have 30 minus 40 is -10. Divide by -7, divide by -7, and one of your solution comes out 10/7. Okay, that's one of the answers. Let me just make sure I did this right. 5 times 8 is 40. 5 times this middle term would just get rid of the denominator, leaving you with -7x. Then 5 times 6 is 30. Then there's this other solution. Again, you're going to have to get rid of the fraction in the middle, which is going to affect all the numbers in the equations. You're multiplying all of them. So your other solution is 5 times 8 is 40. 5 times 7/5 would make that 5 go away in the denominator, leaving you again with -7x as your middle term. And then 5 times -6 is -30 this time. Again, isolating the x term, you're going to bring the 40 over here. And instead of what you got in this scenario, you're going to have -70. Divide both sides by -7, and your other answer becomes 10. Okay, those are your 2 solutions. Okay, then number 13, you're going to try and solve this, isolating the expression inside the absolute value, bringing the 9 over here, which gives you x plus 1 is equal to -7. In this particular problem, you needn't go any further because the definition of absolute value means the distance. And distance, these bars right here mean what is the distance from this number to 0. And distance is always connotated in a positive fashion. So whenever you have an absolute value equal to a negative number, that's impossible. So for this particular case, once you isolate that absolute value symbols, if it's a negative number right here, that is impossible for that to occur. Therefore, there is no solution. Absolute value cannot be negative. Okay, moving to number 14. This video recording device only allows me to do 15-minute videos, so I'm going to go as far as I can. In number 14, you have x to the fourth minus 13x squared plus 36. It says to do this one by substitution. So what you can do is substitute away this term in the middle. So a substitution means you're going to take the squared term in the middle and call it any arbitrary variable that you want. And then you're going to rewrite this and it'll look much more familiar to you once you do the substitution. So don't do the substitution at the highest power. Do it at the power that is half as big as your leading power. So now this is going to be, every time I see an x squared, I'm going to put in a u. Well, x to the fourth is x squared times x squared. So this is u times u. This would be minus 13u, and this would be 36. Now factor this, okay, because you really have u squared. That x squared was u, that x squared was u. You have 36 in the middle at the end. And you're going to factor this to find out what the two answers for u, and then you're going to resubstitute again at the end. This is called the substitution method. You substitute at the beginning, you resubstitute again at the end. So factoring this would be a u at the front of each parentheses. Then the back terms would be, what do you multiply to get 36, but add to get 13, negative 13 specifically. Those numbers would be 9 and 4. Don't forget that out of the 9 and 4, you're trying to get a negative 13, so both of them need to be negative. Okay, you have two factors now. And to get the solutions out of the factors, you make these little baby equations and solve for each little equation, for each first degree equation. Don't forget that when you do get the two solutions for u, you are not really done, because you actually need to find the answers for x. So you have to continue this problem. This is where the resubstitution comes back into the problem. Remember at the beginning we called the x squared because we just wanted to get rid of the higher powers, any kind of funky powers that were in the problem. So going back to this definition, if x squared is u, you can certainly put x squared right back here, so that this will be x squared is equal to 9. That actually has two answers, so you're going to continue solving. You haven't finished yet. We're just resubstituting right now. And we're going to get the two answers that go with x squared equal to 4. So I got rid of the high powers of x at the beginning and then resubstituted again at the end. Continuing this problem. You had one equation that was x squared is equal to 9. And you had another equation that was x squared is equal to 4. Let me let you look at the original problem again. Notice that the original problem went up to 4th degree. And whatever the leading power is, in other words, the highest power, that determines how many answers there are. So you should have 4 answers, and you're about to get all 4 of them right now. Okay, so if you wanted to solve this, you would take the square root here as well as here. But when you're solving anything with an even degree, you need to report both the positive and negative root. So square root of 9 is 3. Giving both the positive and negative root gives you 2 answers. And you can put all your answers in a solution set if they ask you to, but go ahead and get the other two answers. This is, you're going to report again the positive and the negative root. So it's up to you. You can put them in order if you want. You can go -3, then you can put the -2. I'm going from smallest to biggest. And then there's a positive answer, +2 as an answer, and a +3. And those are your 4 answers. Number 15, solve the equation. They ask you to do substitution here. All right, again, you're going to do the substitution at the middle term, not on the higher power. I know you don't think that this is the higher power, but really, this square root, that's the same thing as x. If you don't remember this from Mat 1033, power of 1 with an indexes of 2 is written. Any radical can be written as a fractional power. So you have a power of 1 here, but only a power of 1/2 here. So you're always doing your substitution on the term that has the lower power. So here we go. Again, just use any arbitrary letter. Your book likes to use U. We're going to let U be equal to x to that power that's right there on the center term. In doing this, we can rewrite this equation. These are all called equations in quadratic form. When this power is double this power, those are called equations in quadratic form. Therefore, when you do the first bit of substitution, they all end up factoring. All right. So, in case you don't realize how you get up to a power of 1, that's the same thing. It always relates to this middle term. X to the 1/2 times x to the 1/2. Just like in the last problem, it was this power was double this one. This was x squared, and this one was x to the 4th. And that x to the 4th was x squared times x squared. Well, this one is x to the 1/2 times x to the 1/2. You're always going to see the powers here that are on that middle term. And then in the middle, you have just one of these terms, that's x to the 1/2. So when you go to do this substitution, you have a u for this and a u for this. Then right there, another u, and you have a nice simplistic second degree equation. These substitution problems are a little bit hard to understand because they have a lot of steps. But they want you to solve, they want you to get used to the technique of substitution, where you bring it into a equation where you now recognize how to factor it, yet you were not able to do that when it looked like this. It just looked too crazy. So you have to know a lot of stuff here. When you go to factor, this is going to be u times u. You're looking for two numbers. This is called the guess and check factoring method for trinomials. Two numbers that multiply together to give you 24, but when you add, you get -14. So you want to figure out what those numbers are going to be. We could do, now there's a lot of ways to get 24, but if we're trying to get a 14 out of it, 12 and 2 would work. Now, if you want this to be negative, both of these could be negative. That way, when you add them up, they combine together to give you -14. But when you multiply two negatives, you get a +24. So those are the ones that work. So you now have it factored. Now this video is probably going to cut off in the middle of me doing this problem, but I'll go as far as I can. You have one equation out of that factor, one equation out of this factor. This gives you an answer of 12. When you bring this over here, this gives you an answer of 2. But you're still not done because you are not being asked to solve for u. You're being asked to solve for x. So now re-substitute. This is going to cut off any minute, but I can continue it in the next video. So re-substitute, u is the same thing as x to the 1/2. which is 12. U is equal to 12. Here's my U. And then the other